All right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 212. So today, as Jason realized, we are going to be finishing up the last three topics in the syllabus. It's going to be a rush job. We're going to have to get through it, but we're going to be testing on all this new material on Thursday. I'm kidding. I'm kidding. Of course, we finished the material last Thursday. Today is an extra review day. So like, you shouldn't be falling for this now. Okay. But maybe I got Jason and some other people. Today is a review day. Now, unfortunately, I have not gotten any new info. Let me check once more. Yeah. So I've been sending emails. I've literally been texting them, but I have gotten no new information about the final. So really, yeah, Jason was probably stressed out, so stressed out that he decided to log in even though he didn't know we have class. I sent emails saying what's going on with the final. Is anything going to change with the format? I got some hints that stuff would change, but nothing specific was mentioned. I don't think it's going to change too much. So I'm pretty much going to prepare you in mind for a final of the type that was in the spring, which I don't think it can change much between the spring and now. That was like a month ago. 2 months ago. Things don't change that fast. Like I said, the final in the spring that had 25 problems. You're given 2 hours and 15 minutes. So that's like 5 minutes and a little less than 5.5 minutes per problem. You could not move forwards or backwards. So you started, question 1 shows up. You have to completely finish that, move on to question 2. You're not allowed to go back to question 1. You're also not allowed to look ahead. So you can't view the whole test and pick out what's easier for you to do or whatever. You're just gonna have a question. There'll be, last time in the spring, there was a little comment in the top right or something like that. I think it was the top right. Could have been the top left, but top right. That had like a suggested time limit that you should spend on the problem. So it will say, oh, you should roughly spend about 5 minutes on this problem. And then, so once you know, you have to kind of keep your own per problem time. And so you're just going and you just have to make sure you're not running out in too much time. Of course, if you plan things correctly and you studied right, you'll actually know when you can take a little extra time versus a little less. So maybe there's a topic that you found that's difficult for you. What you would do is you probably wouldn't want to spend more than 5 minutes on that problem, but then on problems that you're really strong on, you know, I can spend 2 or 1 minute on that problem. So that gives me some buffer for the others. But that was more or less the format, was on Blackboard. As for the official date, I'm still getting people asking me, I don't know why, even though I said it on video, it's in the syllabus, it's on the class webpage. The final's Thursday, July 23rd. It will be from 5 to 7:15. Okay, and that is also, you can find that now on the class webpage in the announcement section all the way at the bottom. Yeah. Yeah, they don't know you know the cover-up method, or they don't know that you know the tabular method for integration by parts. So there are a lot of like shortcuts that I taught you that they don't know you guys know. On top of that, the way I've been testing with my test 2 was a little bit different. Test 2, I really gave you a lot of time per problem. It was very close to how it would feel on a final. I would feel that the final would actually be slightly even less difficult than my test was. Yeah, when it came to test 1 and all the quizzes, like I was giving you guys more problems where you were averaging like 2 minutes per problem or something like that. So even though it has all these drawbacks to the final, like, right, you can't go back, you can't change your answer and all that stuff. That being said, 5 minutes should be more than enough for you to handle it after going through my class. And hopefully, if you really go through my past exams, we're going through the review today, you should have no problem in actually getting through whatever difficulty levels. So there were a lot of things that in my test I know that there were a lot of misconceptions. And of course, I kind of sprinkled some questions in there that would test you on these things. So one thing that a lot of people asked me about when I was reviewing regrades and things of that sort was that problem that asked about a limit and whether or not it exists. And one of the options was something like it does not exist because the function is not defined at the point or anything like that. And then the limit actually did not exist, but for a different reason. But I just wanted to throw that out there because it was mentioned in class. Someone said it in class. I don't remember who, about some, well, the function is not defined, so the limit doesn't exist. No, the function not being defined at the point has nothing to do with the limit. They're two separate things, right? And if you don't know those things, it's going to be very tricky, right? So that's where a multiple choice exam will get you. If you don't really know your concepts very well, it can be very tricky. Not that it's hard, because I don't think multiple choice exams are harder than long form exams. But it's easy to trip up if you kind of know stuff. If you actually know stuff, multiple choice exams are easier, for sure. Because you already see some of the answer choices. You can already kind of almost see where the answer would head up. And it's easier. But you just have to make sure that you know your stuff, you know all the strategies, you know all the concepts, you know, for a limit topic, you know all the main concepts that the limit doesn't care about being at the point, it cares about getting close to the point. Whether or not the function is defined at the point is irrelevant, right? We knew this since Calc 1, right? Limit as x approaches 1 of x squared minus 1 over x minus 1. That limit exists, but the function doesn't exist at the point, right? The function existing doesn't have anything to do with the limit. So a lot of little concepts like that will come up and will trick you if you're not careful. And so I kind of wrote my test with that in mind to make sure that you're really solid on the concepts. This will actually get you a little bit better results on the final. Yes, so for the final, I will require that you do write down, and another thing, write neatly, right? If you write, if the scans you submit, like I don't know where you did one question from another, or I can't even read your work for anything, it doesn't really help, right? I shouldn't need a decoder ring to read your work for something. I should be able to say, okay, this is what this person does. I clearly see what they attempted to do. Okay, I can give them some partial credit here. Like more than that, it's not like, you know, I'm like taking it out like, you know, like when those guys are doing the tech and they have those strings connecting the dots with it. Like literally, that's what I have to be doing while grading some people's regrades. Like, what is this person trying to say? Like, it shouldn't be like that. I should basically read it. Okay, they did problem 15 right here. This was what they attempted to write. I see exactly what they were trying, and I can give you credit on that. For the final, I will be asking you to upload scans of your work. And so yes, for potential regrades. And because the final, like I said, is also going to be 4 points per problem. And so that's something that I definitely want to have in there, because you might get something mostly correct, but then you mess up. But again, like that's only going to be as good as how neatly you write and how coherently you write and how well I can follow your answer. If it's like complete gibberish, I'm not even going to bother. So be careful of that. That being said, what we're going to do today is we're going to essentially go through pretty much the same review that I did for my class in the spring. Back then, I didn't know what was going to be on the final either, because everyone does everything last minute in this department. But it over prepared my students for the final, so I'm assuming that it's going to be good enough for us as well as every class will have its own misconceptions, its own misunderstandings about things. And so you guys might have different issues with these problems than the other class did. So we have someone else triggering in here. So without further ado, we are going to, I saw a comment here. Okay, so without further ado, we're going to jump in and we're going to go through these, this stuff. So hopefully you guys are seeing that. Let's stop the video. Okay. So if you guys are seeing this, Math 212 final review. This is it, guys. This is what we've all been waiting for, the moment of truth. Now we're going to see where we are. And I'm going to go through these problems with you guys, of course. But I think it will be very fun for me to do that whole polling feature again, so I can see where the class is at, see how many people have it. And you can actually test whether you know the knowledge or not. You know what I mean? So I think that'll be fun. It'll be exciting. It'll keep everyone engaged, and it will actually give you some idea of where you are versus seeing me doing a problem and then think, oh yeah, I could have done that, when chances are you couldn't, right? You want to know if you can do it or not. So let's actually continue. I actually want to start with a little warm up. What we're going to do is we're going to start by going into some true or false type problems. So really two options here, true or false. And then what we will do is we talk about why those are. And then we'll move on to more things where you'll have more choices. So one thing I did know about the final, which I don't think is going to change, is again, you're going to have 5 options, including a none of the above kind of type thing. So you usually have 4 options and a none of the above, which is it's a possible answer, which is why I put that question on all my quizzes and all my tests, because I know that's how they're writing that at least I kind of know is going to be in the format. I was at some of the meetings where they were discussing some exams, so I know they put that on it. So you're going to have like 5 options with none of the above being included, just so you're aware. So we're going to go through some problems. We're going to go through some true or false, because sometimes they'll have problems like, oh, here are a bunch of statements. Which ones are true? Statements 1 and 2, or statements 2 and 3 only, or all of them are true, right? So you will have things like that. So you do need to have some knowledge of true and false statements as well. So we're going to start there. 2 options, easy warm up. We're going to go through these quickly, and we're going to go through these quickly and just to get everyone up to speed. Okay. No, there won't be any select all. The format was completely multiple choice. So select all was just a quirk of my exams. Okay, let's begin. Ooh, kind of freezing here. And maybe down. All right, let's do that. All right, so here are 10 true and false problems. We'll have more. Let's actually just get into it. So problem 1. So we're going to do problem 1. And hold on a second. Okay, go. You should see that poll. Problem 1. What's the answer? 30 seconds. Go. True or false? So either A or B. A corresponds to true, B corresponds to false. Five seconds. Get your answers in. Okay, we're going to stop there. So we had about 85% participation. The rest of you get on it. Okay, so 85% think it's true. And what we can do is, of course, I mean, do I need to actually write this as true or false? It is true. So that should be true. So remember, if you have something like, r and theta, then if you go to minus r, which would be behind here, and then add pi to that, it will bring you back to theta. So this is minus r comma theta plus pi. And that's r comma theta. So that's actually true. Most people got that correct, which is great. Okay. Go, problem 2. And of course, you guys should be keeping a track of how much you're getting right versus wrong, for sure. The rest of you getting on this polling, I only have about 70% engagement here. Give you guys about 5 more seconds. It's anonymous. There's literally no downside. No one's going to know you're wrong but you. So just do your best. Okay, about 90% participation, but I'm going to have to stop it there. Most people think it's true, and it is true. Because r cosine theta is x, so this is x equals 5. That's a vertical line. 93% thought it was true, 7% thought it was false. Go, problem 3. Poll has been launched. This one is more evenly split. So far, 50-50. But most people think it's true. The trues are just edging out the false, back to 50% each. Interesting. And they're off. A is taking the lead, A is taking the lead, B is trying to catch up, B is trying really hard. I can't do it. Okay, we're gonna stop it, and it's really close. Stop it now. It's 57% to 43%. Is that a circle? True, it is a circle. How do you know? We can multiply both sides by r. R squared equals r cosine theta. This translates to x squared plus y squared equals x. And you can bring the x to the other side, complete the square. You'll realize it's a circle centered at like a half comma 0, with the radius a half or something like that. Just completing the square in my head. I might be off a little bit. But yeah, that is a circle. Go, new poll launch, problem 4. Oh, never mind problem 4. I didn't actually teach you guys that. Problem 5. Okay, I'm gonna cut this off in 5 more seconds. Should really be shorter than that. Okay. All right. And time. Someone chose option I. I think that was a mistake, but whatever. 67% think it's false and 27% think it's true. Now, Yes, thank you for noticing that. This was on our quiz, which means it should have been everyone 100% getting it correct. It is not a hyperbola. This is false. Literally showed up on a quiz before, and I explained this, right? You can't have 0 on this side. This is literally like the graph of an x, right? This means that x squared equals y squared, which is the same as saying x is plus or minus y. It's two like straight lines going at like a big X. It's not a hyperbola. The equation of a hyperbola has a 1 on the other side. You need to know the equation of a hyperbola. Go, problem 5. Problem 6. This one should be quick. Give me 10 more seconds for this. Okay, we'll stop here. 85% think it's a hyperbola. And they have it. It is a hyperbola. Divide both sides by 16. This is like x squared over 4 squared minus y squared over 4 squared equals 1. So this is a hyperbola that opens towards the x and center is 0, 0, and it has an equal major and minor axis. To answer the question in the comments, no, it's not a cylinder, because the question actually specifically says in the XY plane, which means you're thinking of the 2D version. So it's not a cylinder. These would be, the question 5 would be 2 planes if you're thinking in 3 space. And yes, question 6 would be a cylinder in 3 space. Question 7. So see these talking about some vectors, probably sketching it out would be the best way to go. We're looking at question 7. Right, 5 more seconds, get your votes in. Exercise your rights. Okay, and time. A little bit of a race, but not as bad as problem 3 was. 64% believe it's false, and 29% believe it's true. Well, let us see. So here, P, Q, and R are 3 points in space. Here's our P, here's our Q, here's our R. So now PQ is this vector here. RQ is this vector here. Now, if I take, no, that was PR, undo. PQ is this vector here. RQ is this vector here. PR is this vector here. So now the question is, if I take this vector PQ and subtract this vector RQ, do I get the vector PR? Yeah, right? Because this means this, that means PQ is this. And then if I subtract RQ, it goes the opposite way. And so the thing that starts where this guy starts and ends where that guy ends, well, yeah, that's going to be your PR. So that one is actually true. Most people got that incorrect, however. Make a note of that. If you're confused, you need to review vectors. Addition of vectors, you add tail to head, right? So you add a vector by traveling where it goes, then putting another vector where that head is, and then traveling where it goes. So if this is the vector A, that's the vector B, then this is going to be the vector A plus B. And subtracting the vector just means flipping the one in the opposite direction. So if I know that B is this, then minus B is that. So if I were to take A minus B for the example I wrote here, it goes in the direction of A, then goes the opposite direction of B, and then that is going to be A minus B. Okay, so that was actually true. Opposite direction from R. The vectors are PQ, which is this one, and RQ, which is that one. And if you take this one minus that one, you get this one. Anyway, let's keep going. Problem 8. Poll is up. This one shouldn't be so bad. So maybe like 10 more seconds here. Get your votes in. This one's a lot closer than I expected. I think we're striking a chord here. Y'all need to review vectors. Way too much disagreement going on in the polls. Are there lobbyists out there trying to bring some people to one side? I know. Okay, let's actually stop. So it's 64% to 36%. 64% believe it is false. Hold on. Okay, so 64% believe it's false. Now, if we take QP, remember, that's final minus initial. So you have to take the coordinates of P, subtract the coordinates of Q, which means the first coordinate is going to be -1, -2. It's already not that. False. The unit vector opposite the direction vector of this is that. Let me launch the poll. Go. Problem 9. Problem 9. This one's also neck and neck, 50-50, 56-44%. You guys 10 more seconds here. And Kayla, what did you want me to repeat? No, I just read the question. I just read question 9. I didn't make a statement about unit vectors. Okay, let's stop there. It's 62% to 38%. So 62% believe that it's true. Well, let's actually see. So these guys move over. The unit vector opposite direction. How do we find the unit vector in the same direction as x? So u, same direction. This is just going to be x divided by its magnitude. You should know that that's the definition of a unit vector. What is the magnitude of x? It's the square root of the sum of the squares of the components. So that gives you 4 plus 4, that's 8 plus 1, that's 9. So it's divided by 3. So this is, and I can factor that 3 out. Let me not write it as a third. Let me just factor it out to make it look more like the thing here. Factor out a third. And so that's going to be 2, 1 minus 2 times a third. Now I want u in the opposite direction. That's just going to be the negative. Remember, to turn direction around with vectors, you just multiply them by a negative. And that's true. Okay, problem 10. Go, polls are going. A lot of people believe this is false. 85% believe it's false. 14% believe it's true. Now it's 86 to 14. 2 more people left to vote. Get your votes in. Give you guys 10 more seconds. There is a little bit of calculation to do here, so I'll give you guys a little more time. Not that much calculation, but a little bit. 15 out of 16 voted, 93%. Let's actually stop it there. 87% believe that it is false. So most people believe that the vector parallel to that line, by the way, you should recognize that that's the equation of a line. It's the parametric version of a line. And they ask you about whether this vector is, let's move this out of the way. All right, someone tells me like the obvious vector that's parallel to this line. All right, 2, 1, 1. Right. Now, is that parallel to, now the question is parallel to -1, 2, -1. And the answer is no, obviously, right? Because if to multiply the middle, to get the middle term to become 2, I would have to multiply by 2. And to get the last term to become a -1, I'd have to multiply by -1. So clearly I cannot multiply by a single constant to get one to turn into the other, so that it is not parallel. So this is false. Most people got that one. But we are seeing some issues with vectors. You guys need to actually check those out. Okay, let's move on to another batch of 10. We're still in the true or false section, but we'll get to some nicer stuff. Things with more options later. For now, let's move these out of the way. Let's not spoil it. Look at all these treats I have for you guys. Series, you guys remember that stuff? Polar coordinates, a little bit more recent. I won't go through all of those. All this stuff, look at all this good stuff. I think that's it, okay. Just want to move them to the side so they're out of the way. These were some longer form problems. All right, let's get back into this. Go, poll launch, problem 11. A normal vector to the plane blah, x minus 2y plus z minus 1 equals 0 is that true or false? Most people believe it's true. Okay, 77% believe it's true. I'll stop the polling right there. 23% believe it's false. Okay, so for this one, tell me what's the obvious normal, the brain dead normal. Right, 1 minus 2, 1, right? Now, this is actually equal to minus a half times minus 2 for minus 2, if you actually check that. Minus a half times minus 2 gives you positive 1, minus a half times 4 gives you minus 2, minus a half times minus 2 gives you positive 1. So this guy is parallel, so this is parallel to that, which means it is normal to the plane. Therefore, it is true. It is actually a normal vector to the plane. let me launch this again. Problem 12, go. Give you guys another few seconds here. Most people believe that it's false. Well, someone pressed an option F by accident, I guess. But other than that, 100% believe it's false. So let's actually just end polling right there and let's see. So how do these guys compare? Notice that in this guy, let's move this down here. For this to be actually true, of course, to hold K cross J would have to be the 0 vector, but we know it's not. So that's basically it right there. In terms of how the basis vectors work with each other and cross products, again, you can go draw that counterclockwise circle. And you go positive when going counterclockwise. And you go negative when you're going clockwise. So basically from this chart, you would remember that something like I cross J gives you K. You can get J cross K gives you I. And you can get K cross I gives you J, etc. To go with the negative versions, I cross K would give you minus J. K cross J would give you minus I. And of course, J cross I would give you minus K. All right. So we know those won't be 0. Another thing that you should remember, oh, well, we'll deal with those later, I think. So this is actually, yes, it's false. Okay, new polling, problem 13. 15 seconds on this one. It's actually been more than 15 seconds. Let's actually stop it. 77% believe it's false. There's actually a minority that believes it's true. It is false. U cross V is actually the negative of V cross U. The cross product is not commutative. The dot product is. A dot B is the same as B dot A, but the cross product is not commutative. It was a big deal. that we made when we were talking about the cross product. What about the next problem, problem 14, 15 seconds? Okay, we'll stop there. 100% believe it's true. It is true. Right, so the magnitude of the cross products in either order is going to be the same thing. These guys are both the magnitude of the area of the parallelogram formed by U and V. However, they don't technically point in the same direction, but they will have the same magnitude. Poll is relaunched. Problem 15. If U and V are vectors in 3 space, then V dot U cross V is the 0 scalar. Give you 15 more seconds on this one. Oh, it's neck and neck. 57% to 48. Oh, jump now. 64% believe it's true. Okay, 5 more seconds. Get your vote in, the last 3 people. Okay, we'll end right there. 62 to 38. 62% believing it's true. It is true. How do we know it's true? Well, U cross V is orthogonal to both U and V. It's literally what the cross product was meant to model, a vector that's orthogonal to both vectors in the product. So U cross V is orthogonal to V. We also know that if 2 vectors are orthogonal, then their dot product is 0, the 0 scalar. So yes, the dot product of those 2 guys is 0. Boom, go, problem 16. This one's neck and neck. 50-50. It's like it's a complete coin toss. The people who believe it's true is inching it out. 10 more seconds, last 3 people. Come on. Oh, it's nice. Like you guys can't see it being animated, or is that just me? Really? I thought you guys were seeing this because yeah, I see the bars moving as people are voting. And I mean, I can share the results. I mean, you guys can see it now. There it is. But I thought you guys were seeing it while it was going on. So yeah, there you have it, 50-50. True or false? No. So I'm gonna do the Thanos snap here. Just indiscriminately kill half of y'all. All right. It is true. By properties of cross product, constants can factor out. And then I can swap the cross products and get the negative. And then I can multiply the constant on that one. So it is true. So those of you who got that, you survived the snap. The rest of you, hopefully the Avengers can help. But okay. Problem 17. And I kind of already told you guys the answer to this. Eliminate my family. Okay, so now I don't know this one because I literally told you guys the answer a little while ago. Okay, so we'll stop here. 58% believe it's true, which is, I mean, we did it down here. It's I cross K. So I cross K, we know that that's minus J, right? So this is false. So remember how the chart is set up. IJK running around counterclockwise, like a circle is the positive direction. Negative direction is going the other way. Once you figure out all the positive ones, it obviously going the backwards is going to be negative. So that's false. So yeah, there you can see the results, 58% to 42%. Most people got it wrong. Okay. Boom, go, new poll, problem 18. We're getting close to the end of the true or false problem, so we're gonna kind of switch it up in a little bit. If the vector y is a scalar multiple of the vector x, then x cross y is the zero vector. True or false? Ten more seconds on that one. Okay, end polling right there. So as you can see, 58% believe it's true. And while it is true, surprised a lot more people didn't get it. So vectors, clearly an issue. We're definitely striking a chord here. You guys need to review your vectors, know about dot products, know about cross products, and pray that you don't have a lot of vector questions on the final, because it seems to be a coin toss at this point. The cross product is the zero vector whenever the vectors are parallel. Now, if y is a scalar multiple of the vector x, that means that it is parallel to the vector x. So therefore, the cross product is going to be zero. No calculations necessary. You kind of just have it there. So, okay, new poll launched. Problem 19, if x and y are vectors in 3 space, then x cross y plus y cross x is the zero vector. Go. 10 seconds for this one. Because we did something earlier that should tell you what the answer is. Okay, we're going to end polling here. And there you see it, 62% believe that it is true, while 38% believe that it is false. It is true because we know that x cross y is the negative of y cross x. So therefore, if you add them, you get the zero vector. That we even mentioned this earlier somewhere. Oh yeah, I literally mentioned it right there. It was in view of the question. Yeah, so know about that. Cross product of 2 unit vectors is a unit vector. True or false? There's a canonical example here. Actually, there are 3 canonical examples that would describe the answer to you. By the way, if I'm not mistaken, this was also a quiz problem. And it's still an even split. Do you guys actually review the quizzes after I give them? Natalie is finding this the easiest decision of her life. Well, it should be. It's one of the easiest. The only decision that could have been easier was problem 19. Okay, we'll end the polling right there. 54% believe that it is true. Let me share the results so you can see it. 54% believe that it is true. 38% believe that it is false. And once again, most people got it wrong. It is false. Cross product of two unit vectors is not a unit vectors. Like I said, 3 canonical examples. I cross I is what? It's the 0 vector, right? J cross J is what? The 0 vector. K cross K, the 0 vector. In fact, remember, if you take X cross Y, you get 0 if X, Y are parallel. So all you have to do is take 2 parallel unit vectors and you cross product them, you will get 0, which is not a unit vector. So that is actually false. Do we have more stuff? Yes, a lot. Okay. I had more true and false than I expected. I thought I had like 23. Guess I just forgot. Okay, let's get through the last batch here. Let's go quickly so we can get to bigger, better things. Yeah, sometimes people select, it's not even A or B. Like, I don't know. I don't know what's going on. Okay. Pay attention. Cross product of 2 perpendicular unit vectors is a unit vector. No problem, Kayla, and you're all welcome. This is okay. We'll end right there. No, these problems that we have here, I scoured the internet for them. I don't think the book has a lot of multiple choice or true or false answers. And even your online homework system doesn't have a lot of multiple choice or true or false answers. So yeah, I had to go and find these guys. So I got a bunch of things that I think are of reasonable difficulty for the class. And yeah. All right, now this one. Now the last question showed that we can cross product 2 unit vectors and get 0, which is not a unit vector. So you might think that this would be false based on that. However, it is true. 77% thought of that. And now, why is it true? Remember, the magnitude of a cross product is going to be the area of the parallelogram formed by the 2 vectors. If the vectors are perpendicular, it means that the parallelogram they form is a square. Therefore, the magnitude of the parallelogram, quote unquote, formed by the vectors would have area 1, and the cross product will have magnitude 1. So if we have 2 vectors that are perpendicular, the cross product is going to be 2 unit vectors that are perpendicular, the cross product is going to be a unit vector. And in fact, if you have any 2 vectors that are perpendicular, the cross product will have the magnitude of the rectangle formed by those vectors. So the cross product is just going to be the magnitude of one of them times the magnitude of the other. So that is actually true. Problem 22, let's get through this quickly. The set of points x comma y comma, the set x comma y comma z such that x squared plus y squared equals 1 is a circle, true or false? 10 more seconds for this one. Let's go. We'll end polling there. 69% believe that it's false. 31% believes that it's true. It is false. This is not a circle. In 3 space, which is indicated by the fact that we have x comma y comma z coordinate, which is 3 coordinates, which means we're in 3-dimensional space, x squared plus y squared equals 1 is actually a cylinder. It's a circular cylinder running along the z axis. Okay. Next problem, problem 23, true or false? Ten more seconds. Okay, we end there. 87% believe it's true, and 13% believe it's false. It is true. That is actually a circle. How do I know? We have x comma y, so it's in 2 space, and that follows the equation of a circle in 2 space. Who's the 13%? I don't know. It's like the 1% versus the 99%. Well, I mean, there are only a handful of you here. So 13% sounds like a lot, but I think it was like 2 people out of those that voted. 24, the point blah lies on that curve. Poll launched. Okay, this one's not so bad, so 5 more seconds. Okay, stop there. We have 77% believe that it's false, 23% believe that it is true. Well, quick check, just plug in the points. So this is -2 squared, -3 times -1, +1 squared, -9 times -1 squared. So that's going to be 4 minus 3 minus 9. Yeah, that's not 1, so it's false. Go. Next problem. The graph in the x, y, z space, the equation this is an elliptic paraboloid. So I've given you enough time to kind of jog your memory. It's not really, it's also something that you should kind of just know based on the definition. 83% believe it's false, 17% believe that it is true, and that is straight up false. This guy is going to give, like right there, you can actually see with the negatives there, you're going to get a couple hyperbolas in play. In fact, this looks like a hyperbola of 2 sheets or something like that. it's not a elliptic paraboloid for sure, because with the elliptic paraboloid, one of the variables would not be squared, and then it would be equal to the sum of some squares of the other two. So that is what gives you an elliptic paraboloid. Okay, go. Next problem, 26. The two lines quoted there intersect in one point. Some of you answered really quick there. I don't know, did you actually do the calculations or are you just randomly guessing? Okay, let's stop there. 67% believe that it is true. They do intersect in one point. 33% believes that is false. Let's actually look at what that would look like. Those two lines, do they intersect or not? Well, you would actually set up the equations, and I would use a different variable for the parameter in one of them. Let's use like S. And the second one, it's minus 2t plus 1 equals y. And the third is 4t, and the other one is s plus 2. So now we kind of want to solve this one. So for example, I can get in the first one that your t is equal to 5s plus 10. Plug it into this one. So that's going to be 20s plus 40. So this means you have 19s is equal to minus 38. So that your s is equal to minus 2. And then this would mean that your t is equal to, well, 5 times minus 2 plus 10. This is 0. Now you just see, does this work? So if I plug in t equals 0, I get 1 on that side. This should be s. Now, if I plug in s equals minus 2, that would be 6 minus 5, which is 1 on that side. So it actually checks out. And so it's true. These guys do intersect. Problem 27, that line and that plane intersect in one point. Now, this one can actually be done in a little less time. So let's actually, because you don't have to do as many calculations to figure this one out. Okay, let's stop right there. We have 91% believing that that is false. So let's actually look at that. Let's move this over here. How do you know if this intersects? Well, you'd plug the points from the line into the plane. So you'd replace the x with t plus 2. You'd replace the y with minus 3t plus 1. You'd replace the z with 2t minus 5. And you would see, is that equal to 3? Well, on one side, what you would have is t minus 3t plus 2t. There's 0 t's here. Then you'd have 2 plus 1 is 3, minus 5 is minus 2. So you have minus 2 is equal to 3. That is absurd. So no. In fact, you can check pretty easily that this line is actually parallel to the plane. And so if you got an intersection, by the way, quote, the line is parallel to the plane. So if you found one intersection, there would be infinitely many. So as long as the line is not parallel to a plane, it's going to intersect in one point. If a line is parallel to a plane, then it will either never intersect, and you'll know that because when you plug it in, you'll get a nonsense equation popping out, or it will always intersect, which means if you plug it in, you'll actually get an equation that's always true, something like a 0 equals 0 or something like that. So it will always intersect. How do I know this line is parallel? Well, the direction vector for the line is 1 comma minus 3 comma 2. If you take the dot product with the normal vector to the plane, which is 1 comma 1 comma 1, you will get 0. So the line is actually orthogonal to the normal vector of the plane, which means it's parallel to the plane itself. And so that is means it will either always intersect or never intersect. And in this case, it never intersected. A new poll is up. Problem 28. If two lines in three space don't intersect, then they must be parallel. This is more of a concept question here, so I will give like 5 more seconds. Okay, we'll end. There are the results. 90% believe it's false. So if two lines in three space don't intersect each other, they must be parallel. We know that this is false. We learned about things called skew lines in three space, which means that it's possible for two lines to not intersect and at the same time not be parallel. The answer would be true if we were in two space, but it's actually false in three space, which is very important. Okay. Go. Problem 29. P1 and P2 are two planes with normal vectors n1 and n2 respectively. If the vectors n1 and n2 are not parallel, then the intersection of P1 and P2 is a line with n1 cross n2 as a direction vector. People are sleeping on the skew option. Facts. Okay, so we'll stop right there, share the results. Now, for those of you who have been studying correctly, now I never actually tested you on a problem of this sort. And that's because it will take a lot of time to actually do it. So there were a lot of problems in your homework and in the practice problems that were about finding the line of intersection of two planes. It involved you taking a bunch of cross products and stuff, so I never really tested you on it. However, on your homework, you should have done stuff like this, and you would realize that if you were asked to find the line of intersection between two planes, this is exactly the procedure that you would do. You would first find the normal vectors for each plane, which might involve taking cross products in the first place. Then you would actually take the cross products of the two normal vectors to find the direction vector for the line. So as a matter of just knowing about the process for solving such a problem, you would know the answer is here and that it is actually true. And the reason is because the normal vectors are orthogonal to the plane, then anything that's orthogonal to both normal vectors will be parallel to both planes. And a line that's in both planes is obviously parallel to both planes. And so that will give you the direction vector. All right. Go. Problem 30. Give you guys 15 seconds on this one. I also believe this was a quiz problem. I'll give you guys 10 more seconds. Won't need a lot of time here, especially since we actually discussed things today that would let you know what the answer is. Okay, so we'll stop. 67% believe it's false. Literally today, I showed you that I cross I is the zero vector. Notice that neither of those guys is the zero vector, and the cross product is zero. Remember, cross product equals zero does not mean that one of the guys in the product is zero. It means that the two vectors are parallel. Therefore, this is actually false. Okay. Remember, the products in vectors, you can't think of it like you think of multiplication of numbers. Multiplication of the real numbers, then this is true. If you have one number times another number and you get zero, then one of the numbers, one or both of the numbers must be zero. This is not true with vector products because vector products aren't really like multiplication at all. You can't really multiply or divide vectors. That operation doesn't really work on them. The products, the dot product and the cross product were just ways to combine vectors to get some meaningful information. The dot product was a way to combine to get a scalar that tells you the angle between the two vectors. The cross product was a way to combine two vectors to get a vector that is orthogonal to both of them. So these are more procedures. Yes, they're called products, but they do not really have anything in common with the word product from the numbers system that we're familiar with. So things of that sort. Okay, let us go to the next problem. Problem 31. I believe this is actually the last true or false problem. So let's actually finish this one with a bang. If u dot v is the zero scalar and at the same time u cross v is the zero vector, then one of the vectors have to be zero. Either u is the zero vector or v is the zero vector. And I was hoping for 100% correct on this one, but my hopes have been dashed. We already have disagreement, 70% to 30%. So problem 30 might have hinted to some people that it's going to be false. Well, the cross product is zero. It doesn't mean that one is zero. But we've also introduced the information that now we know the dot product is a zero scalar. So pretty much remember what it means for a dot product to be the zero scalar. Remember what it means for a cross product to be the zero vector. And that should tell you what the answer is. Okay, 5 more seconds here. The other two, get your answers in. Okay, so in polling there, 77% believe that it's true, while 23% believe that it is false. It is true. Why is it true? Well, dot product being the zero scalar means the vectors are orthogonal, which means they are perpendicular. They meet at 90 degrees. If the cross product is zero vector, that means that the vectors are actually parallel, which means U and V, we end up in the scenario where they are perpendicular, they're orthogonal, and they're parallel at the same time. This would literally mean if your vectors are non-zero, they would have to be a vector that points in two different directions at the same time. The only vector that can do anything like that is the zero vector. The zero vector is the only thing that is both orthogonal and parallel to everything. And so somebody here has to be zero. One or both people have to be zero. Zero vector is going to be the only vector that can do that, be orthogonal and parallel at the same time to some other vector. So yeah. So there we go. All right. Jeez. That was a long warm up. Okay, let's get to some more problems here. So this one, not true and false, but still not like 5 options, not anything too crazy. Boom. I believe problem 9 was actually also a quiz problem. Or something similar to it. Poll is on for problem 9. The integral of the form 0 to infinity of f of x dx. Is it impossible for it to have a finite value? It may or may not have a finite value, or it will always have a finite value. So far, 100% are going with the may or may not. One person going with it always has a finite value. Future engineer hopeful. And we also have one person thinking that it can never have a finite value. It's always going to go off to infinity. Okay, let's stop there. So we have 8% going with option A, 85% going with option B, and 8% going with option C. The answer is, surprisingly, option B. Well, not so surprisingly. Of course, whenever it has a finite value, it's a very beautiful thing and it is insanely useful. I made that engineering hopeful comment because when you in your engineering classes and some future math classes, which are very useful for engineering, integrals going from 0 to infinity are going to be very useful in doing certain transformations, most notably the Laplace transform. And this allows you to calculate a lot of things very nice. Engineers love the Laplace transforms. It's actually an integral of this form going from 0 to infinity. It may or may not have a finite value. If we look at something like 0 to infinity of 1 over x dx, we know that that diverges off to infinity. However, if we look at 0 to infinity of 1 over 1 plus x squared dx, we know that that is finite. That goes to the arctangent, which is, I think that adds up to pi over 2. We did an example like that in class already, memory serves. Okay, so it can be infinite or it can be finite. There are both options. Launching the poll for problem 10. Evaluate the improper integral. You cannot use a lifeline. This one's for all the marbles. Two people answering very quickly. Okay, I think that's enough time for this problem. Okay, so as you can see, no one thinks it's A. We have 36% believing it's divergent. Also 36% believing that it's 1 over 3e to the 3. And we have 27% believing that it is D, minus 1 over 3, blah, blah, blah. Let's actually see what it is. Let me move this polling box out of the way here. So, of course, minus 1 to infinity of e to the minus 3t dx. Now, technically, I think this was a typo because this should have been I think you want to look at it this way. What's going on? Right, now, with the 3t there, it would be divergent, technically. So this diverges. Now, if you pick that because you notice that this was a t, because e to the minus 3t is a constant with respect to t, with respect to x. So that's a constant times x, and then you're going to plug in infinity for x is going to blow up. However, I do believe that this was a typo. I think what was meant was this, and I feel like a lot of people read it that way anyway. Let's actually see what that is here. So you would just integrate this. This is minus 1/3 e to the minus 3x between 1 and infinity. And then, yes, technically you're supposed to write limit as n approaches infinity of 1 up to n of blah, 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 whatever. So we know that when we plug in infinity into the power, that's going to go up to 0. Then we're going to minus when you plug in 1 into the power. And so that'll give you positive 1 over 3e cubed. So if we're looking at it how it should have been typed, which I think you want to think of it as an x here, then that would be the answer. Now, having a different variable in your integrand from what's out here, that is actually something that you will see in the next class. It's not really something you would see here, which is why I believe it was a typo. Because at the Calc 2 level, you don't do partial integration. We've only done partial derivatives. But partial integration is kind of a thing. You call it iterated integrals though, and you'll usually have more than one integration sign when you want to actually do that in general. Problem 12, poll launched. The point 3, 2, 11 will be blank units above the XY plane. 4 options here. Ten more seconds, the rest of you get your votes in. We'll end polling right there. 8% believe that it's A, 23% believe that it's B, 69% believe that it's C. It is C. The Z coordinate tells you the distance you are from the XY plane. Nothing else to say about that, I guess. Problem 13, poll launched. Okay, I'm gonna stop it in like 5 seconds. Okay, there, 90% believe that it's B, 10% believe that it is C. It is B. Set y equals to a constant, that means the equation becomes an equation of x and z, which would be projected in the xz plane. It will be parallel. Y equals a constant, if you look at that in 3 space, if I pick a constant here, y equals a constant, that is just a plane that looks like this. This is the plane y equals c. It is going to be parallel to the xz plane. So you can draw it that way, or you can just realize if I plug in y equals a constant, that's just going to mean that my variables are now going to be x and z. So those are the guys that I would have to focus on. Boom, boom, boom. Okay, go. Match this graph with the equations. Okay, it shouldn't be taking so long, so I'm going to end 5 seconds. Polling end. 64% believe it's A, 18% believe it's B, 18% believe it's D. And the answer is, drum roll, it's A. How do I know? This is a cone, upside down. It's actually should be pretty easy to do also by process of elimination. That's a plane. You should know that that's the equation of a plane, right? So it's a flat sheet, doesn't work. This guy here is a paraboloid. You should know that. And in fact, it's a paraboloid that opens up, right? So it opens like that. So it's not that. This is not a graph that we've seen, but if you just actually kind of just look at how it behaves, you'll know that it won't be the guy. Because this looks like z equals 1 over x squared plus y squared. Notice that as you approach the origin, this guy blows up, right? So it goes shooting up to infinity, right? And it would kind of, so this kind of tells you at 0, it's definitely not going to stop at 1. It's going to get bigger and bigger and bigger and bigger the closer you get to 0. It actually blows up to infinity as you approach 0. So even by process of elimination, choice A should be the obvious answer, but you really should know what the equation of a cone looks like. Z equals the square root of x squared plus y squared is a cone. Make it negative, it flips the cone upside down so the pointy end sticks up, and then you shift it up by 1, which is why the apex here is at the height of 1. Okay. Problem 15. This one shouldn't be too bad, so I'll give you like 10 more seconds. Okay, so I have 30% believing it's A and 88% believing it's B. Of course, the x-intercept means that y equals 0 and z equals 0, which means when you plug it in here, you would get 2x equals 18, which would give you that your x should be 9. So you have 9, 0, 0. It is B. Okay. Boom, 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 boom. Here's one on partial derivatives. Find the second partial with respect to y, f sub y of this equation. Didn't launch the poll. Let me launch the poll. See where we're at. Fifteen more seconds. Let's go. Okay, polling ends. 75% believe that it's B and 25% believe that it is D. Of course, here f sub y means you differentiate with respect to y, which means you think of every x as a constant. Think of x ln y, so that would give us x over y because you differentiate the ln, leave the x alone because x is constant. Here, your e to the x is a constant and you differentiate with respect to y, so that leaves you with e to the x. Then you're going to differentiate with respect to y again. So this will give you minus x over y squared, and that's going to be 0, so it is B. Hold on. Let me pull up the next question. And it's another true and false out of nowhere. The poll is already launched though, so go. I'll give you 10 more seconds here, but it really shouldn't take that long. Because we're in 91% say it's true. The others say it's false. Of course, the limit as x, y, z approaches a 0, a 0, a 0 of sine of x plus y plus z over x plus y plus z, that is equal to 1, special trig limit, which is actually equal to the value of the function defined at that point, which means it's actually true. It's continuous. So it's only defined as a sine function divided by that thing when we're not 0. However, it is continuous because the limit exists and it approaches the value of the function at that point. Okay, so those are some long form answers. Maybe let's look at a couple series problems. Maybe this, not all of these. Series, see who remembers series. Okay, do that series problem that's right there. Let AN be a conditionally convergent series. Which of the following is not necessarily true? So you might have problems like these on your exam where it's like they number the statements and then you have to choose 1 is true, or 2 and 3 is true, or 1 and 2 is true, or they're all true, or they're all false. And those would be the options. By the way, we've been at this about an hour and a half at this point, and we've done way more problems than you would do on the final. We did them in shorter time, and it wasn't really any more difficult than the final was in my remembrance of it. Just your daily dose of reality here. Okay, let's actually stop there. Share the results. Okay, so most people think that B is the one that's not necessarily true. Some people think that C, so we have 64% going with B, 9% going with C, 18% going with D, 9% going with E. So the series converges to some finite value L. Yeah, that's kind of what it means to converge. That's actually true. The sum of the series is independent of the order of terms. That is false. So that was a big deal of why we cared about absolute convergence versus conditional convergence, because absolute convergence series are the same regardless of the arrangement of the terms, whereas this is not true for conditionally convergent series. If I know that something is conditionally convergent, that means that it's not absolutely convergent, right? That's true, because if the sum of the absolute value of the terms converge, we would not call it conditional convergence. We would call it absolutely convergent. The limit of this is 0. That would, of course, be true because for something to converge, the limit must be 0. Even though it's not necessarily true that if the limit is 0, it converges. But if we know it converges, that the limit of AN is 0. And if you multiply that by a plus or minus 1, you're still going to get 0. So that's true as well. So pretty much B is the only one that is false here. So that in the plot twist is the correct answer because it's the only one that's wrong. And this asks you about where it's wrong. Now, launch the new poll for this one. Which of those series converge? About half the people have voted so far. Give you guys another minute. Let's go. Ten more seconds. Share the results. So most people believe that A converges 45%. No one believes B converges. Interesting. C, 27% believe that that converges. 9% believe that D converges. And 9% believe that E converges. 9% think that F's converge. And even though there's no choice F. Let's actually see. Anyone see anything weird about this problem? Yeah? What's weird about it? What's the con thingy at 1? I don't know what. It means for all x. The upside down A, it means for all. Right. So this, I think, was a typo. This is, there were actually two possible answers. A and E both converge. In fact, they both converge absolutely. This guy here is literally the definition of e to the x. Right? That's your Taylor series for e to the x. This guy here actually converges absolutely. You can use the ratio test. This guy here, these two, it should be obvious they diverge. Test for divergence will tell you that those diverge. So if you think those converged, you need to really go back and study that series chart because that should not be something that would trap you here. B is a little bit interesting. It does diverge. Test for divergence would not help you though. You do a comparison. Compare it to 1 over n. Now, if you it's going to be weird to compare it to 1 over n with the sign jumping up and down, because sometimes it's going to be larger than 1 over n, sometimes it's going to be smaller than 1 over n. However, if you do a limit comparison, you can alleviate those concerns. So something like a limit comparison. But these guys actually have two answers. How long did I give you to answer this question? Oh, it doesn't record the time I took, but maybe like 2 minutes, which is actually more than enough. I mean, C and D diverging at this point, I think should be obvious. Like you should see that in 2 seconds. B might give you a little bit of pause, but then you'd realize, you know, the sign is actually not going to cause that to get any better. It's almost a harmonic, and you have a sign in the bottom. That's not going to be anything that should converge. But if you have doubts, do a limit comparison with 1 over n, and you'd realize that the limit is going to be about 1. And so that actually does the same thing as 1 over n. Then if you look at the first one, that you should immediately know is the definition of e to the x. That converges absolutely to e to the x for all x. And the last one, it has an exponential in the top and a factorial in the bottom. So the factorial grows a lot faster. You're going to think this decreases to 0 very quickly. Even though you're taking a square root, it doesn't slow down a factorial that much compared to an exponential. So throwing that into a ratio test, you should kind of see that that limit is going to go off to 0, actually. That's going to converge very fast. So that actually converges. Okay, let's do. But yeah, so a problem like that, I actually think, well, if it's properly written so that there's only one problem to ask, a problem like this, I think, could potentially show up on a final. It would be something that they would give you 5 minutes for. Honestly, I'd expect my students to do this in under a minute, if that. But let's go with that. Consider the series e to the n over n factorial. If the ratio test is applied to the series, which of the following inequalities results? Implying that the series converges. So they're even telling you that that series converges, but again, to my students, that should be obvious. But pretty much plugging it into the ratio test, what is going to be the result that tells you it converges? Okay, I'll give you guys 1 more minute. We've been hacking away at it for about 1.5 minutes so far. Okay, about to stop. Okay, ending poll. Yes, Kayla, have fun. All right, so here we see that we have D. I mean, I always post my notes, but yeah. Anyway, here we have D is in the lead with 56%. 22% believe A, 11% believe B, 11% believe C. Okay, so let's actually look at this. Now, to plug it into the ratio test, you should know what that looks like. This is going to look like the limit as n approaches infinity of an plus 1 over an. And you want to check that that is less than 1. So this would look like e to the n plus 1 over n plus 1 factorial times flip. You would get that. Now, of course, you can see that this e to the n is going to cancel that guy, and this n factorial is going to cancel that guy. And so you would actually end up with the limit of e over n plus 1 in absolute values. Now, of course, n is already 0 or bigger. It's 1 or bigger according to this. So this is actually positive. So this is actually equal to the limit of e over n plus 1. And of course, that's less than 1. In fact, this guy is equal to 0 as n goes off to infinity. So it looks like it's D, which most people got. That's what most people thought, 56% being the most people here. Okay, let's look at this one. Interval of convergence. Now, in general, these problems can take a while. However, for this one, 15 seconds should do it. Okay, we'll stop right there. It's more than enough time. Like I said, in general, what you would do, ratio test. Everyone knows ratio test. This one, though, is a little trick because it's geometric, which means automatically that we just need that x over 3 in absolute value is less than 1, which means that your x in absolute value should be less than 3, which automatically means that it opens up to -3 and 3. And we know for the geometric series, it diverges at the endpoints because if your x is 3, this is just a series of 1. And that diverges. If x is -3, then this is -1 to the end. That also diverges by the test for divergence. So this is D. And so a lot of people thought it was B, and I think because they just saw the x over 3, they thought it was over 3. But remember, you have to set it less than 1, and then you'd have to multiply both sides by 3. So that leaves you with D, 33% getting that. And 33% going with B, which I think was an algebra error. 70% with C and 70% with E. Okay, so at this point, we've been hacking away for about, well, a little less than 2 hours. But I think since we started this whole review session, it's been about 2 hours. And I think we should probably stop here. So here's what I will do now. Okay, so let's stop there. Been a lot. So what I can do is I can actually just post a PDF and have the other problems there as well. And you guys can do it on your own and see how it goes. So here's the thing. I'm open to having another session tomorrow. So I don't know if you guys would be up for that. So the option is I can leave the files in a PDF for you to do them on your own, or I can hide the rest of the problems and we go over them tomorrow in another review session. But if you don't want, that's fine. I'm fine with not having one. I'm definitely not having one on Wednesday, you know, because I need a vacation. As well as I asked, hide them. Okay. So I can hide them and we can do this again tomorrow. And whatever we don't finish tomorrow, I'll just leave them up. And what I would also do, I was trying to get one of the other instructors to share some of their quiz questions with me. And so maybe I might even have some other problems created by one of the other instructors to share with you guys as well. So yeah, we are looking at that. Other than that, we're going to wrap up today. We've actually been hacking away for a while. The brain needs rest. I'll have these guys hidden and we can actually meet tomorrow. For those of you who can show up, we'll do the rest and then I'll just leave the others in a PDF. That being said, any parting questions for me before we go? So the final is on Thursday, July 23rd at 5 to 7:15, as I recall. And it's going to be on Blackboard. It's going to be multiple choice. You're not going to be able to move through the exam. Mentioned all of that. Any other questions? There are still some regrades left to do. Also, I didn't update Jupyter after doing some of the regrades for test 2. So just give me some time for that. For the final, yeah, I would suggest that you write everything down. Pretty much if you don't write down something for whatever reason, then there's zero chance of you getting partial credit for it if you get it wrong. So look at it that way. Like you can't explain to me on the spot the answer to a question because I don't know if you knew that at the time of the test. So if you don't show work for anything or any problems that you don't show work for, then your hopes of partial credit goes to 0. So pretty much write down everything that you're hoping that you can get partial credit on. If you're so 100% sure that you got it correct, I guess in theory you don't have to write anything down, but it's better if you do write things down. You never know. So yeah, I will actually open up something in Gradescope where you would submit your scans for the final. But it will be multiple choice on Blackboard. It'll be 5 options with none of the above, as far as I know. Tomorrow we can have another review session where we go through some of the other problems. There's some more stuff on series, some more stuff on some other topics that we didn't cover on. One thing we did learn though, you guys have to review vectors a lot, cross products, dot products, planes, equations of lines, everything that has to do with a vector and using a vector to construct an equation. You guys have to look over that. There were a lot of issues there. That being said, we will end here. Hopefully I have some more problems for you tomorrow. I didn't get a response from the people yet. And maybe, hopefully, I hear a response from the course supervisor about the format of the final. If there are any changes, I'll update you guys as soon as I know. That being said, I am going to log off. Stay safe, everyone. I'll post a video of this as well as a PDF of the problems that we did so far. I'll hide the other ones and we'll go over those tomorrow. And that is that. So good night, everyone. Until then, stay safe and I will see you in the next one. Ciao.